All right. Good afternoon, everybody. My name is Ali. Actually, I can turn on the video as well in a second. All right. So I will just briefly give an overview of what I do at OzU and elsewhere, and what the research projects I've been working on. And as you can imagine, we are always looking for some good grad students who will take part in these projects as a research assistant. So PhD or master's obviously is a long-term commitment. It takes a lot of energy, commitment, and it's not really that easy to sign up for such a long program actually in our country. That's that's obvious. I think there was a presentation yesterday by the dean who talked about the financial topics related to graduate programs. And then I hope you can survive with that kind of financial aid for a couple of years. But then later on, I promise you that there will be many other and much better opportunities for you, to grab. So there are all these scary stories about graduate student life, papers not getting accepted, miserable salary for a couple of years, sleepless nights, long projects, paper rejections and everything. But it's really, it's just a very limited amount of time. And then, eventually you will survive and you will hopefully get into a really nice position. So you need to survive a couple of years, and then it will, it will make much more, it will become much more, productive and profitable. So, usually master's is a couple of years in our university, and the PhD is about like 5 years. But this is really up to you. It's, we certainly have some requirements in terms of paper publications and citations and things like that. But, if you do a good job, and then if you work hard enough, you can actually finish it in just a few years after you finish your coursework in your PhD. If you're a good undergrad student, you can start your PhD right away. If not, then you first need to do your master's and then maintain a good GPA and then continue to your PhD. Now, I'm not going to talk about those topics anymore, but obviously you are welcome to contact me or any of our faculty at any time if you have any questions. So I'm going to talk about multimedia today, what I've been working on for the last 20 years, actually. That's also the area where I did my PhD. And, when I was doing my PhD, obviously I wasn't really expecting that I will have such a long run in this topic, but apparently I might just retire from this business as well. So it has been a great run, actually. So when I talk about multimedia, at least for me, it is mostly related to systems and networking, applications and protocols, that sort of thing. There is all kinds of other multimedia domains like haptics or visual senses, sensors, and stuff like that. And unfortunately, I'm not really working on those topics. So, if you look at my research, we are going to see it's going to be, related to networking, systems, applications, and protocols. So, well, what about me? And then, a couple of things about my research. Well, I was born and raised in Konya, and I'm still currently living in Konya. I did my bachelor's in Bilkent in 2001. That's when I graduated. And then I moved to Atlanta, Georgia to finish my PhD in electrical engineering and computer science. In 2006, I finished that. But in the meantime, I was at Qualcomm in San Diego for a year for an internship. And then I moved to Bay Area, worked for Cisco for about 9 years in San Jose, California first, and then in Toronto, Ontario. And then the last 2 years actually being back in Konya, remotely working. I came back, I got married, and then I worked for another 2 years in Cisco, and then started at OzU University in 2016. And then since then, I've been, I've been involved in this university, and I'm doing also my consulting work. So this is something I already mentioned. I've been lucky enough to work with some great people and students and my colleagues at Cisco and, in other companies as well. I was lucky enough to get a number of awards and distinctions. These are obviously, you need to be in the right position at the right time with the right people. Otherwise, all these require hard work and dedication. But the good thing, the necessary thing is really to, be lucky enough to be at the right place at the right time. So most recently, the Emmy Award in Engineering and Science was, it was a first for this country. I was very happy to receive that. This was earlier this year, and actually the actual statue is still supposed to be mailed, so it can be any time, but I still haven't received it. Probably before Christmas or after Christmas, I should be able to get some pictures for you. So in terms of work experience, I did an internship at Qualcomm for about a year, working on 3G standards at that time, link layer and the physical layer stuff. I'm actually not that low-level guy, but that was really an interesting topic during my internship. And then I was at Cisco for about 9 years, as I said, in the video and content platforms group. And then OzU University, and then starting with OzU, I also have been running my own consulting company. Currently, I've been for about 6 years now consulting for Comcast NBC Universal as well. I am very active in standards development, which is something I think a lot more people from our community should be doing from this country, but it's really at a very low participation level at this point. All these organizations are obviously very important organizations in the multimedia domain, especially online content distribution and delivery. Consumer Technology Association, Dash Industry Forum, IETF, SVTA, MPEG, and then other ones like 3GPP, DVBH, BPTV, SCTE, and W3C. If you look at these organizations, there are multiple billions of dollars of work being done every year, but there is no single participant from any Turkish company or Turkish university, which is really a big shame. I've been trying to hold an MPEG meeting in Turkey for the last 5 years or so. We were hit by a couple of unfortunate events in Turkey. The meeting was canceled, and then COVID has happened. But this time, hopefully in April, we are going to nail it. There will be an MPEG meeting in Antalya in late April next year. And then, Dash Industry Forum has been to Turkey before, but other organizations are obviously quite North American centric. And IETF is somewhat very picky in terms of venue selection. So Middle East countries are not really their top choices for visiting. So what do I do in terms of research? Enough for the introduction. So my research is really primarily multimedia applications. And the nice thing, or the distinct thing about multimedia applications, is that they generate a lot of data. That means they also require a lot of bandwidth and storage capacity. And often this data is also time critical. So it's not like you can store the data and then you can use it like minutes or hours or days later. Usually we need the data in real time, or in just a few seconds, we need to have that data delivered to somewhere. And another distinct characteristics of multimedia applications is that there can be multiple flows, but all these flows are not really dependent from each other. There's all this intraflow and interflow semantic relationships, which really complicates a lot of things when it comes to protocol design or application development. So we need to find the right set of APIs in the application layer to expose to lower layers or to other applications, so that we can keep the complexity manageable while we are still trying to use our resources in the best way possible to achieve the best performance, whatever that performance criteria is. It could be the best video quality, it could be the highest fidelity content, whatever. But our goal is always to use our resources in the best way possible, so that we can achieve our objective as good as we can. So to do this, we have a number of protocols. There are lots of them. We develop new ones, like every year or so. And then all these protocols have certain bits on the wire specifications, which are standardized. you need to follow them. But then there are a bunch of algorithms within each of these protocols that are up to implementation. Different companies have their competitive advantage, so that they can, improve things a bit better than their competitors, for example. So that's where, differentiation among different vendors comes into place. So to do that, we do need to model all these protocols or applications or algorithms. We need to prototype them, and we need to analyze the systems, right? It's a whole very well-defined kind of work. But then, the algorithms, protocols might change, but the strategy is more or less the same. Now, with more and more features we have in the network, or on the network equipments, like we used to have network processing units, NPUs, but now there are even like some GPUs being installed on some network equipment for a lot more deeper inspections, or a variety of things that we would never imagine like 10 years ago. We are doing a lot of stuff within the network, for intrusion detection, for security threat modeling, for botnet detection. That's one area that I'm not really actively working on, but it's a very interesting area. And then all application-oriented networking. We all have these very well-defined routing algorithms, for example, but different applications might require different routing mechanisms. So, routers are now, some of them at least, are capable of doing something like that. There are software-defined networking tools, which where you can program the network to do some specific tasks for your application or your services. But the bottom line is really, we want to make sure that the network actually empowers our applications, because network is a tool for us. It's not really the goal. I am not really a networking guy per se. I am really an applications guy that is trying to, abuse the network as much as possible in the most scalable way possible, and so that I can get the most reliable service, and hopefully a secure service as well for my purposes. It could be media delivery, it could be real-time communications, it could be cloud gaming, it could be streaming, whatever you can think of. Yeah. So looking at the end-to-end paradigm, this is a very simplified diagram. On the left-hand side, we have the content capturing or content production side. It could be a live sports event, it could be off the disk, it could be from a pre-recorded content or live studio content, or it could be just a linear broadcast. We have this encoding stage. Obviously, encoding is where there's a lot of money. There's hundreds of billions of dollars that are actually being spent on encoding and its technologies every year. And then there is encryption, packaging, storage components. There is all this origin, service origination components. And then, in the middle, we have the scalable and reliable delivery part, whereas all these different delivery architectures come into play. Content delivery networks, 5G, 6G, whatever you want to call it, smart Wi-Fi, Wi-Fi 6, cellular networks, satellite networks, low orbit satellites, whatever. And to do reliability, to achieve reliability as much as we can, obviously we need to have an understanding of what's really happening within the network. And for that, we have lots of analytics and delivery performance tools, which actually do real-time analysis of what's happening in the network. And on the right-hand side, we have the consumption. It is usually us, but now it could be machines, it could be something else, it could be another entity, or it could be input to another system, where all this content, multimedia data, whatever it is, it could be the World Cup final game, or it could be Olympics, it could be news broadcast, or it could be a Zoom meeting, whatever, right? All this is going to be consumed by all these devices. And as I said, we have all these flows with interflow semantic relationships, and we have flows with certain timeliness requirements. So things need to be done in a certain amount of time. Otherwise, you better not do it at all, because you are going to be wasting resources. So my research for the last 20 years has pretty much touched on all these blocks, which are in red color. I'm not really much of an encoding person per se, but obviously you cannot just refrain yourself from that part either. It's an essential component because you need to understand how this media data is generated, so that you can do clever things in terms of delivery and consumption. So if you look at research projects, they will be touching one or more of these red blocks in this diagram. Now, the Emmy Award we got, earlier this year was about this MPEG-Dash standard. I just want to say a couple of things because this is essentially what probably everybody is using every day without probably even knowing it. If you are streaming YouTube, Netflix, Disney, or whatever, you are more or less using this technology behind the scenes. So again, we have the content on demand or live. There is a content preparation stage, like cameras, microphones, and then everything, encoding, packaging, encryption. And we produce the same content in different fidelity points, like different resolutions and bit rates. And then everything is distributed over a CDN or multiple CDNs on any network to any device. So you can watch your World Cup games on your iPhone versus computer versus TV or Apple TV, Roku box, whatever you like. And this is all enabled by this technology that we have been working on since 2010. So the whole idea is delivering entertainment content to any device on any network, and then hopefully any time. Obviously, there are some geographical limitations, like a content might or might not be available in a certain country or in a certain IP subnet and that sort of thing. But those are business decisions. In terms of technology, we can do whatever we want today. So our goal was really to produce common standards. There were standards, or there were at least proprietary ways to do it before MPEG-Dash, but our goal was to come up with an international standard, a cost-effective one and a ubiquitous one to enable this service to anybody in the world. So when we are doing this, obviously, we are not just doing the protocol work, we are actually doing the research side as well, because again, a lot of things are specified in the protocols or standards, but a lot of other things are left for implementation, for innovation. So how we can improve the quality, given the resources and given our requirements, what is the best way to improve video quality or streaming quality? When you are watching football game, obviously there are a lot of factors. The picture resolution, bitrate, whether it's HDR or SDR, whether you have multi-channel audio or not, white color gamut, frame rate, when you are adaptively streaming, how frequently you switch the resolutions, bitrates, and then everything. How frequently you need to freeze, or you need to freeze for a short amount of time or for a long amount of time, and then how close you are to the live point. Obviously, 10 years ago, when you were streaming live content, you would be like 60 seconds behind live content. But today we can do live streaming at 5 seconds or 10 seconds latency without a problem. Yes, there could be still problems, but we are in a much better shape. And then we are trying to push the envelope so that we can do sub-second latency. And then I have a couple of people, working on a project for that. So maybe one more slide. This is also very important. Something I've been working for about 7 years. Something I started at Cisco, and then it became a standard. And then, the initial standard wasn't really picked up by the industry, but eventually all the CDN companies felt the necessity for this, and then we revised it, and then now it is shipping in a lot of products and servers. So whose fault it is when something is not working right? So you are a Netflix user on your tablet or on your iPhone, and if the Netflix quality is not as good as you expect, then what do? You can blame your phone company, you can blame your cellular company, network operator, you can blame Netflix, whatever. But at the end of the day, you are not going to get your money back, because all these services are best effort. Nobody's really promising you anything. So how we can identify where the problem is, so that it's not really just to get the money back, but really try to fix the find the issue so that we can actually fix it. So we have done this standardization, which is the first part was published 2 years ago, and the second part, complementary part, was published just actually last week. Common media server data and common media client data. And these are all being used by the 3 largest CDN operators now, Akamai, Cloudflare, and Fastly now. So I think it's a very big accomplishment in all industry. And we will see a lot of benefits coming out of this in the years to come. Because now, people will not be able to just blame someone else for a problem. We will be able to find where the problem was, and so that we can fix it. So, okay, I have one more slide for the latency. So in 1969, this is something I use in my slides actually. The single largest broadcast event was apparently moon landing. I wasn't born at that time, but my parents do remember that. And it was reported, we don't know the actual number, but it was reported that 650 million people around the world globally watched this live broadcast. And astronauts from the surface of the moon, they were doing a very simple audio video broadcast analog at that time. And that was around 250,000 miles away. And it was just under 3 seconds. If you compute the speed of light, it's already a few seconds already for that kind of distance. And imagine that all that signal acquisition and transmission and then delivery in the entire world happens under less than 3 seconds. In 50 years later in Atlanta, Georgia, Super Bowl 53 was one of the first Super Bowls that was streamed by a big provider. And then we had all these fancy technology like 8K cameras, augmented reality, and everything, and then all that stuff. But even if you were just a few miles away from the stadium, the latency for the streaming was over 5 seconds, which was a really big shame. Today, yes, we are in a much better position. We can do it like around 5 seconds, and that might still be long, but that's more or less what broadcast latency is anyway. So it's not as far as the moon, but still there's a lot of stuff happening, and due to digital broadcasting, obviously there are some delays that we cannot avoid. So 5 seconds is actually a pretty good latency for these kind of events. But the nice thing is that we can do this to your iPhone, we can do this to your tablet, we can do your Android phone, computers, browsers, and anything, your connected TVs. That's really the work we are trying to do over here. Okay, so over the time of 6 years, I graduated a number of students, mostly masters. But my first PhD student graduated, in summer this year, and then I currently have 2 PhD students and 1 undergrad student working with me. And obviously, I have way more problems that I can work on myself. So that's why I'm looking for more students. If you decide to do a master's or PhD, preferably PhD, because that's where you are going to contribute a lot more, because it's a longer term commitment as well. I can promise a couple of things. First of all, you are going to have great time. You are going to get a lot of experience, and then hopefully, if you do a good job, you will get a pretty good job after graduation. So looking at my students here, Mehmet is in UK, Burak is going to a PhD, and then work for Cinemedia in France. He just finished his master's. Ömer Faruk, I think he's the only one in Turkey. He's working for Getir. Deniz, he did. He was just an undergrad student, but he published 3 papers with me. And he's at now Simon Fraser University in British Columbia in Canada, but he's going to Apple for internship. Kerem is in UK, Adem is in Norway, and Şevket is also in UK. So I try to get all of my students abroad as much as I can, because that's where you should get really the most of the experience. And Zafer is here currently working on his PhD, and Tuğçe is in Germany, and Fatih is undergrad, but hopefully he will start his grad student studies very soon, early next year. All right, well, that's done. I managed